Hi class, and welcome to SigFig notes. So SigFigs, I'm going to tell you right now, can give you a headache, and they can be a little confusing, but the more you practice them, the better you will get with them. So for example, we have the Atlantic Pacific rule. So what this rule tells us, that is, if a decimal point is present, aka P, we're going to start on the Pacific side. So we're going to start on the left-hand side, okay? And we're going to count all digits as significant after the first non-zero, okay? The other part of that rule is the Atlantic rule, which is if a decimal point is absent, okay? You begin on the Atlantic side, which is the right-hand side, okay? And you're going to start counting from the first non-zero, okay, all the way till you run out. So let's do some practice problems. So the first one that we have is 0.0860. So you can see that the decimal point is present. So we're going to start on the left-hand side. Okay. We're going to start on the left-hand side. So we're going to start with the first non-zero, which would be the 8. Okay. So we count there, 1, 2, and 3. We have 3 significant figures. Moving on to the second one, again, it is also present, so we're going to start on the left-hand side. Our first non-zero is the 1. And counting over, you have 1, 2, 3, 4, 5, and 6. Those 2 zeros at the end are significant due to the fact that they tell us that there is not something in the thousandths and 10,000ths spot. Now, our next number, there is no present decimal, so we're going to start on the right. Okay. And we start with the first non-zero, that would be the 4. And we count from there until we run out. So 1, 2, and 3. So that one also has 3. Now, the next one, you can see that the decimal place is present. So we're going to, again, start on the left. The first non-zero is that 1 out front. And we're going to count from there on. 1, 2, 3, 4, and 5. Our last example also has a decimal point present. So we're going to also start on the left. And starting at the 1. 1, 2, 3, 4, and 5. Now, what I would like you to look at is how this number and this number are numerically the same. However, one has 2 more significant figures due to the fact that there's a decimal. And this is when those rules come in handy. Another way of thinking about SigFigs is about leading zeros, lagging zeros, and sandwiched zeros. So I can talk about both ways of SigFigs, but you might find one easier for you to remember than the other. So for example, leading zeros, never will we ever count them. Okay, so never. So for example, on this one, you're not going to count the 2 zeros in front, but you'll start with the 2 and count from there, giving you 2 SigFigs. The other 0 is lagging zeros. Now, these ones you have to have a decimal. So we're back to, hey, does it have a decimal or does it not? So for example, 76.20 has a decimal. So you're going to count all of them, including the lagging 0, giving you 4. 760 here has no decimal place. So we only count all the non-zero numbers, which gives us 2. And sandwich zeros. What I always like to say is if your mom or dad or yourself packed you a lunch and you had 2 slices of bread stuck together, is it a sandwich? No, it's just 2 slices of bread. So in order for it to be a sandwich, there's got to be something in between. So what's in between matters. That's the key. What's in between matters. So this one has a decimal place. It doesn't matter. That sandwich 0 counts. So we have 4 SigFigs. On the last example, we also have 4 SigFigs because sandwiched zeros count. All right, so we're going to go forward. This is just a general counting how many SigFigs are in each number, but you also will be applying this to mathematics. Okay, so first we're going to do some rounding. So with rounding, you want to identify the SigFig that you're rounding at. So for example, this is 42.56. We want to have it as 3 SigFigs. So we count to the third SigFig, which is the 5. And we're only looking behind the 5. So behind the 5 is a 6, making this 42.6. Okay. We're not going to continue to round up. It's not a rounding train. You only round in one spot. The next one, again, at 3 SigFigs, so you have a decimal, so you count from the left. 1, 2, 3. The third SigFig is 6. 7 rounds 6 up, giving you 207. We're going to try these next numbers. This one we're going to 2 SigFigs, so 8 and then 5. 5 being the second SigFig, giving us 8.6. Now, what if it was 8.5 and it was 1 SigFig? Well, 8, 5 behind the 8, it becomes a 9. Okay, 1 SigFig, it could happen. It doesn't happen very often, however. 164.2, we're going to 3 SigFigs. The third SigFig is the 4. 2 doesn't do anything to 4, so it's 164. All right, now let's talk about a little bit of math with this stuff. So the biggest thing about addition and subtraction with SigFigs, okay, you still have to do the mathematical operation to get an answer. And it's your answer that will then round with SigFigs. So how we say it is we want to keep the least digits to the right of the decimal. So the little saying that I've always used is we do least. One second. We do keep. So you're going to keep all the digits in front of the decimal. It doesn't matter. And then we'll go to the least. Okay. So again, you want to do the math first. So on this one, you'll see that it becomes a 2, a 0, and then a 1, and a 2. So we keep everything in front of the decimal. So that 21 is going to stay no matter what. Now behind, you're finding the least digits behind the decimal. So you might also say the least common place value. So the last common place value is the tens place. So we're going to keep the 0, meaning that my final answer after SigFig rounding is 21.0. Okay. And yes, that 0 is necessary and it is important. So for the next one, what we're going to do is we need to add those two numbers together. So with your calculator, take 1.203 plus 6.99. It gives us an answer of 8.193. Now, we need to round. According to SigFigs, we're going to the least to the right of decimal, the least. So this has 3 and this has 2. So my final answer can only have 2. So we're looking at the 9. So behind the 9 is a 3. It doesn't round it, giving us 8.19. Okay. The next question is a subtraction question. So we will subtract it. You'll get 42.00. When you round this, we're going to the least. So this has 1, this has 2. So we're going to 1 behind, giving us a 42.0. Now, I'll be honest, the addition subtraction rule is the most difficult of the SigFig rules. You'll be able to do the multiplication and division much easier. So, for example, for multiplication and division, you still got to do the calculation, and then it's just the least total. So you take 6 times 12, okay, and 6 times 12 is 72. Okay, you only have one SigFig with the 6, meaning your final answer has to be 70. Now, the hardest part about this is remember that 0 is not significant because there's no decimal place. So please be cautious about your decimal places. When you perform this in your calculator, you get a final answer of 2. However, in order to have the proper number of SigFigs, you'll see that this has 2 and this has 2. So your final answer will need to have 2 SigFigs, giving us 2.0. And because there's a decimal place, this 0 counts. On the final answer, you get 160. Now, this, I will be honest, can be a little bit tricky because 16 has 2. How many does 10? 10 only has 1 SigFig. So my final answer can have 1 SigFig. Okay, so with that, you'll round up the 1 to make it 200 without a decimal place. I hope this has been helpful. If it's not, below is, or if you still have additional questions, I should say, below is an additional resource that you might want to take a look at.